axis. Tell me what goes on X, Eric. All right, what goes on Y, Brian?
The 100 grams of distillate.
All right, so I need the 100 grams of water. All right, what needs to go on top of it? Can somebody tell me what goes on top of the 100 grams of water? All right, the grams of solute. All right, so what do I need my line to do if it's decreasing, Jennifer? What do I need my line to do if solubility is decreasing? It needs to go down. All right, what else did I ask for in that question? I said label where it's saturated, unsaturated, and supersaturated. All right, where is it unsaturated, Trent? All right, at the bottom. So what do you mean by the bottom? Be more specific for me so I can label it up here. Leave Trent alone. What do you mean by the bottom? How would you tell me to label it when you say the bottom? You want to draw it on the board? Okay. All right. So under the line. All right. Where's saturated at, Betsy?
No, saturated. It's on the line.
All right. Saturated is on the line. All right. And where's supersaturated, Juliana? Above the line. All right. The last two questions are just descriptions. How do I tell if something is unsaturated, Destiny? Okay, that's the definition. How can I tell that it's unsaturated, Bryce? Okay.
You can still see it. And
Is dissolved. All right, you can't see it and you can't feel it. So if you were making something like Kool-Aid or coffee or tea, the sugar would be what? Dissolved. You wouldn't be able to feel it. You wouldn't be able to see it. So the opposite would be true in saturated. What would you see or feel in saturated? You'd be able to see the tea or the sugar or the Kool-Aid or whatever it was that you were dissolving. It would be there. You'd be able to see it or feel it. Questions? Because there's nothing saying they'll give you a graph. They might give you a description of a question and give you chemicals and describe what's going on in the solution. And if they describe something bottom, that will tell you the solution is what? Saturated. If something's sitting at the bottom of the beaker, that should tell you it's a saturated solution. Questions? All right, find your graph from yesterday. Talk about questions C and D, and then we need to add a question and talk about how you do that too. All right. Does that make that any better or does that make that worse? I don't guess it's too bad. All right, so there's our graph. I asked you to tell me the temperature at the solubility of 275. So what do we have to do if I want to find temperature? Salma, what would I do? If I need to find the temperature on the exam for a solubility of 275, what do I do? Or if that's your benchmark question tomorrow, what do you do tomorrow? No idea? Tim, what would you do? And see, if they give you a solubility of 275, how do you find the temperature that goes with that solubility of 275? Okay, so Salma's got her finger on over here, so she's doing what? So she's tracing it from the 275 over to the line, and then she's doing what? Going down. All right, mine's not at 40. Mine's in between.
I said 37.
Mine's in between 35 and 40.
I said 36.
Mine's gonna be closer to about 35, or between 35 and 40. So mine's looking like 36, 37. All right, depending on what your graph looks like, yours might look different. All right, mine looks more 37-ish the way my graph is drawn. All right, yours might look different. So when you write your answer down, remember units. Some of y'all lost units on your lab reports too. Wrote calculations down and put no units on the answer. So 37 degrees Celsius. All right, now D. Look at the way the question reads. If you have 100 grams of silver nitrate in 100 grams of water at 10 degrees Celsius, would the resulting solution be saturated or unsaturated? Could also be supersaturated. All right, I just got lazy. So 100 grams at 10 degrees Celsius. We got to plot that. So find your graph. 100 grams at 10 degrees Celsius puts me right there. Where am I in relation to the line? I'm below the line. So what kind of solution am I? I'm unsaturated. Okay? Same thing in the next question in D. And again, I got lazy. So is it supersaturated, saturated, or unsaturated? What would happen if we have 325 grams of silver nitrate in 100 grams of water at 35 degrees Celsius? So 325 at 35 degrees Celsius. So 325, 35 degrees Celsius, and we are, looks like right there. Hey, Mr. Shupin, how are you today?
I found your solution, so I finally returned it.
Oh, thank you. I'd forgotten all about it. You want her back?
I do. I know she can't get to school on time most days.
Well, she doesn't show up most days. She's still convinced that the 23 absences she had in the computer articles, y'all marked her absent when she was at Jackson Academy.
Right.
It's y'all's fault. So you really need to get on top of that, fix it. Okay. You do. So when you look at that, where's it at?
It's above.
It's above the line, so it's what?
Supersaturated.
Supersaturated. All right. The last question we're going to put on this one, because this is more likely what I think you'd see on the exam. If, let me see. Let me make sure I word it right. So I'll do something stupid. Then you go and swallow it. That doesn't make any sense. All right. Let's say how many grams of silver nitrate can be dissolved in 200 grams of water, let's just say in 50 degrees Celsius, or at 50 degrees Celsius. Okay, let's do that. Okay, write that down. How many grams of silver nitrate in 200 grams of water at 50 degrees Celsius? Now, yesterday, when we were doing the graphs, I told you that all the graphs will be done in 100 grams of water because we can't have a third variable on the graph that's changing, right? However, we can change the amount of solvent in the question. We just have to know how to find the answer when we change the amount of solvent. And it's not hard.
Can you zoom in on that a little bit?
Can I zoom in? Sure. Is that good? It'll clear up here in just a second. It's still zooming. All right, how many grams of silver nitrate can be dissolved in 200 grams of water at 50 degrees Celsius? So this time, I have done what in the question? I have altered our amount of water. This time I've made the amount of water what? 200. Is our graph 200 grams of water? No, our graph is how much water? 100. So we're going to read our graph in 100 grams of water, and then we'll compute the 200 grams of water. All right, so read your graph with 100 grams. What did I give you in the question to read? The 50, okay? So, let me see if I can get my graph here. All right, so 50 degrees Celsius is here. So where am I going? Up to the graph, which is, looks like a little more than my crosshair. So that looks like what, 375 and a little more. So what are we going to estimate? About 380? Somewhere about 380. All right, so I get 380 grams per 100 gram of water. Now, the problem is my question wants to know per what? 200 grams. So, what happened to my amount? Surely you hadn't quit already. What's wrong? Did you lose your papers? Did you make copies of it?
One of those days.
I have them all the time. So, what happened to our amount of water? It doubled. So, what are we going to do to our amount of solute? So, you're going to double it. So, 380 times 2 is what? Somebody tell me. 760? That would be your answer. Questions? Any questions about how we did that? Everybody okay with that?
Yeah.
All right.
Wait, how'd you do 760?
Because the amount of water was doubled. You okay with how we doubled the water?
Okay.
So we doubled the amount of solute. All right. Now, the last thing I want to do with the solubility graph is I want you to read one with multi-lines. A couple of years ago, this one was actually on the exam. Most of the time, the exam questions they release, I shouldn't say release, have at least 3 or 4 lines on it. This one has more than 3 or 4. So, we want to do a graph that has multi-lines. And then we're going to learn 2 new skills today. And then with the exception of doing acids, bases, and nuclear, we're going to be okay on the benchmark tomorrow. Nuclear, we're going to do Friday and Tuesday. And then acids and bases, we will pretty much not have time for. I'll hit the highlights as we review. All right, so on the graph I just handed you, okay? Answer as many questions as you can before we go over it. See what you can do with that. I think I have this one that I can pull up on the smartboard. Answer what you can.
All of these salt.
Are what? All of them are salts if they're ionic compounds. All right, that's the definition that I haven't talked about because we haven't done the acids or bases yet. But a salt is just another word for an ionic compound. So anything up here that's ionic is a salt. So like Ki is ionic, so it's a salt. Things that are not salts would be like NH3 because that's covalent. NH4Cl is not a salt. I think those are the only 2. Everything else is a salt. All right. Did you send that to me, Juliana? All right. Did you send it from your personal or the school one?
Personal.
Okay. Might be why I didn't get it. Do you have a school one?
It's not working yet.
Okay. Give it time to see if it shows up. Anybody have a question? All right, be right. All right, who's got a question? Give me all time to get started. Anybody? So, it's like, I think I got it. So we're testing chloride. We're testing chlorate. Chloride is KCl. Mhm. Okay, and that's for 100, and you're doing it for 200, so.
That she did.
Because the people who were watching with glassware were like ducks. They got water everywhere. Good job. Okay.
It's like, I'm confused with 8 and 10. They got it wrong.
Got done, Dusty?
How do you, did I calculate this right?
All right, KCl, potassium chloride is gonna be KCl. So you're doing 80 degrees up to KCl. So here, all the way up to here would be 50. So it's 50 grams per 100 grams, right? But it said per 200 grams. So what do you have to do is 50.
Is it always every time schedule?
Nope, and this one you're doing what? Yep.
Did you like it?
That's not actually, that's not just.
I think they did get you.
Questions?
Not just confused with, this is potassium nitrate.
That's nitrate. Potassium nitrate.
So it's just something, so we go
Yep.
40.
Yep, up there.
I was saying, I don't know, this one, yes, which one? But that's not pretty cool.
I can just watch it.
You're going from, you're doing it from 40.
46 or something like that.
Yep, and you're gonna estimate, so 40 up and over, maybe 42
Okay, that's
would
actually.
be an estimate I'd make.
Are you doing great?
You said it's 40. Yeah, I'm basing it off.
Yes.
Just a quick scan, you have no units on 2 and 3, and I don't like to, other than that.
That's like 20. Yeah.
Who's still working and needs a couple more minutes?
Me.
All right, I give you about 2 more minutes, then we're gonna go over it. There's a lot of folks who are done and waiting. Uh-huh.
How do you, find the, if it's most soluble or least soluble?
Most soluble would be where on the graph?
Definitely.
At where on the overall graph? At the top, bottom, middle, where? Top. For least soluble, you'd be where on the graph? Yes. All right, let's look at what you came up with. All right, so in question 1, you've got which salt is least soluble. All right, what did Benzabay and I just talk about? If you are least soluble, where do you have to be on the graph? At the very bottom. All right, and it gave you a temperature at 20 degrees Celsius. So you're talking about this line right here at 20 degrees Celsius. So at 20 degrees Celsius, who is at the absolute bottom? KClO, and that's supposed to be a 3, not that this graph is very clear, but KClO3 is the compound that's at the bottom. Okay? Any questions about that? All right, number 2. All right, it wants you to find the solubility of potassium chloride. Some folks had trouble with this because they got confused between this compound and this compound. Which one of those is potassium chloride if it ends in IDE? KCl. Remember, IDE means you're binary for the benchmark tomorrow and the exam in 2 weeks. What is IDE? It means there's how many capitals? Only 2. And this one has how many capitals? 3. That one's going to be on your polyatomic ion sheet. Okay? That's going to be the IDE. So, what temperature did that give us a number 2? 80. So, find your 80. Go up to your KCl line, which is right there. Read over, and what do you get? All right, so that was 50 per how much water on this graph? Per 100, right? But did the question ask you per 100 grams? It said per how much? Per 200 grams. So the water did what? So what do you have to do to the 50 grams? So when you wrote your answer on the line, did you write what I have right there in the box? Or did you just write 100? If all you wrote was 100, you're going to lose points on the quiz because you didn't write the full answer. It's 100 grams per 200 grams of water. You have to specify how much solvent you use. You can't just write 100 grams. All right, number 3. This time they want to use what compound? Potassium nitrate. So which one up here is potassium nitrate? KNO3. So this time we're using this compound. What temperature did they give us this time? 40. So this time we're going 40 up to KNO3 is right here. So it's a little past the crosshairs. So we have to estimate and run over about there. So what do you estimate that to be? 42, 43, either one's good. All right, 42 grams per 100 grams. All right, so if you did that, the question said per 300 grams. So this time what happened to the water? It tripled. So what do I do to the 142? So you would have got 126. If you had said 43 grams per 100, you got 129 grams per 100 grams. Now, if your answer is not exactly that because you estimated slightly different, is that wrong? No. Okay? Just make sure that your answer is multiplied by 3 per 300 grams also. Questions on 2 or 3? All right, number 4. Which salt shows the least change up here? Which one shows the least amount of change? NaCl, all right? Because if you look at the line, it's almost what? It's almost straight. And if you remember what I told you yesterday, I think I said it in this class because I'm teaching the same concept right now in physical science too. If you remember what I said yesterday, salt, it doesn't really matter if you use cold water or hot water. What happens when you add the salt? Its solubility is roughly the same. It doesn't matter if it's cold water or hot water. Very little of it's going to dissolve. Okay? Number 5. At 30 degrees and 90 grams, sodium nitrate is what? Degrees and 90 grams. What is sodium nitrate? I'm going unsaturated. I'm going with it's a little below the line. All right, so I just said it was unsaturated because it's below the line. For me to be saturated, it has to be where? On the line. Is it on the line? No. So I just said unsaturated. I know a lot of you would have looked at that and probably said, it's close enough, it's on the line, and said saturated. But for me, is it on the line? No, it's not on the line. It's below the line, so I'm going to say it's unsaturated. All right, number 6. A saturated solution of potassium chloride is formed from 100 grams of water. If the saturated solution is cooled from 80 to 50, how many grams of precipitate are formed? All right, so they gave us 2 temperatures and they told us a compound. So what are we going to do with potassium chlorate? Potassium chlorate is KClO3, and they gave us 2 temperatures. So what are we going to do with that information? What do we need to find? Okay, so they gave us 50. So 50 up to potassium chlorate is right here. So what am I going to find with that? I got the temperature, 50. I went up to the line. Okay, go over to the grams. So I know the grams for that is 20 grams. Okay, what else am I going to do? Find the 80. Go up to the line and go over, and it's 40. All right, so now I got the 40 grams. So what am I going to do those 2 numbers y'all got for me? Subtract. That's going to tell us what precipitated. So what do I get? 20 grams is what's precipitated. Very good. Any questions about that? All right. Number 7. What compound shows a decrease in solubility? What do we do to find the decrease in solubility? So who goes down? NH3. All right, most soluble at 10. All right, so here's the 10 line. All right, what do we talk about for most soluble just a second ago? Where you got to be? At the top. So who's at the top? Very good. All right, so Ki is at the top. Number 9. Which salt is least soluble at 50? So here's our 50 line. Who's least soluble at 50? All right, number 10. I purposely didn't answer when I was walking around because most of you have the wrong answer. Now, look at what I have written up here on the board in green. KClO3. All right, which salt is least soluble at 90? All right, it has to be an ionic compound, okay? And a lot of you picked this one because you said, oh, this line is least soluble. But is NH3 an ionic compound? No, it has to be a metal and a non-metal. So the first metal, non-metal is this line right here, which is NaCl, okay? Now, why do we call NaCl a salt? Because it's the most common salt, all right? But all ionic compounds are salts. Questions about reading a solubility graph? Yay or nay? All right, we're going to do one other short concept that I debate skipping, so we're not going to spend a lot of time on it, but molarity and dilution are the math calculations we're going to do today, okay? So, and they're pretty easy because you already have all the skills you need for that. We're just going to use what you already know. All right, so we're going to talk about like dissolves like today. Now, this again is a topic that you already know the content or should know the content. This is where those of you who don't keep up and don't study and have forgotten a whole bunch of stuff, it's not going to make any sense to y'all. Those of you who have kept up and know what I'm talking about, you're going to be like, oh, this isn't bad, Miss Wall. So I can't fix it for those of you who haven't. Now, like dissolves like is just a rule of thumb. Essentially, it means polar compounds dissolve what? Based on what I've written at the top of the board. Polar compounds. Now, if polar compounds dissolve polar compounds, what would that say about non-polar compounds? They dissolve what? Exactly. All right, so non-polar compounds now, where we have trouble is when we throw in alcohols and ionic compounds. Alcohols can dissolve both polar and non-polar compounds. Not ionic. All right. Alcohols can dissolve both polar and non-polar compounds, not ionic. Ionic compounds can only be dissolved by polar compounds. Now, those are basically the 4 rules you have to know. The first 2 aren't hard. Those are basically the rule that's underlined up there. Like dissolves like. So the only 2 you really have to remember are the bottom 2. Alcohols can dissolve both polar and nonpolar compounds, not ionic. And ionic compounds can dissolve only polar compounds. Are we caught up? Because we got to talk about 2 vocabulary words you might see. All right. The first vocabulary word is the word miscible, which means can be dissolved. And the other one is immiscible, which means cannot be dissolved. All right, you got it? Any no's? I'll take that as a yes. All right, which of the following is Ki miscible in? All right, let's go with water. Let's go with ethanol. Let's go with CCl4. Could you stop that?
Huh?
Could you
I keep yawning. I can't do it quietly.
do it without the noise? I yawn all the time, and I can do it without that high-pitched squeal. Okay?
Yeah.
Now, in order to do this, all you have to do is figure out what the compounds are. All right? We've studied bonding. You have to be able to figure out what kind of bonds they have. Are they polar, they nonpolar, they ionic, they covalent? What do they have? Okay? So, starting with a question. What does Ki say to you? What does it speak to you and say I am? Well, that's a good answer. At least 2 people said ionic, and Sarah Ellie mouthed something back there. That's at least 3 out of the 19 people that are here. So the quiet ones out there who are just looking at me or looking down at their paper. Do you understand why they said ionic? Okay, I said, did this compound here speak to you and say I am what? Do you understand why it's ionic? Yay or nay? Why, Liliana? Since you said yes. There we go. Does everybody understand what Liliana said? Yes, Tim? Okay, so we know that this is ionic. Now, if we know this is ionic, now we need to know what these things are. What do we know about water? This is one I would have just memorized. If I don't know it yet, I would memorize it for the exam. What'd you say, Jennifer? All right. If I don't know that yet, I would learn that water is polar. Okay? But let's pretend for just a moment that you have forgotten. Since you have a benchmark tomorrow, and you might need to know something about a Lewis structure. Does anybody remember how to draw a Lewis structure? And the exam, is in 2 weeks, and you might want to do well. Okay, so we got an O in the middle and an H on each side. That is fabulous. How do we know how many electrons we need, Betsy? Okay, so how many H's do we have? How many O's do we have? And how do I come up with those outer shell electrons? How many does H have? Because it's in group number. Okay. And how many does O have? Because it's in group number. Fabulous. So we get 2 and we get 6 for a grand total of marvelous. Everybody okay with the people who said 8? Great. So who is not getting dots in this structure? Cannot have them? The H. Can it have a double or triple bond? No. The only elements that can have double or triple bonds cannot be an H, right? H is never getting dots, it's never getting a double, it's never getting a triple bond. Everybody remember that? So all the extra dots have to go on what element? Okay, just making sure we're all there. All right, so I'm putting my bonds between the O and the H. So there's 4 of them. Where are those other 4 dots got to go? On the O. So to figure out this is polar, what 2 rules do I use to figure out it's polar? Okay, so the electrons are called lone pairs. Okay, so I look here. Do I have lone pairs on the central atom? Yes. Okay, so if I have lone pairs, we said that automatically made it polar. Okay, so that's why it was polar. All right, the second rule we had was, were these bonds the same? So were the bonds the same? Yes. Okay. So in this particular example, we had, yes, the bonds were the same. We had lone pairs, so that was a no. That's why it was polar. Okay. Now, if Ki is ionic and water is polar, are these going to be miscible? If we go back to the rule, whoops, not far enough. Is an ionic compound going to dissolve in a polar compound? Ionic compounds can be dissolved by polar compounds. Yes. So, whoops, not far enough. So the answer here is, let me pick a different color. Yes, miscible. All right. Now, what's this end in right here? So, what do you suppose ethanol might be? That's an alcohol. Okay? This is an alcohol. So, what's the rule say about ionic compounds and alcohols?
It can.
All right, it will dissolve both polar and non-polar, not ionic. So, no, it is immiscible because it will not dissolve anything that's ionic. Okay, Ki is ionic, will not dissolve ionic. All right, CCl4. What do we know about CCl4? It is all right, is it ionic or covalent? Let's start there. It's covalent. Okay. So we do know that it's covalent. All right, so we need to figure out if it's polar or non-polar. That's where we need to go with that conversation once we know it's covalent. Okay, so how do we decide if it's polar or non-polar? The Lewis structure. Okay, so how many electrons does carbon have? 4. How many does chlorine have?
7.
Times how many chlorines? 4. So 7 times 4. So everybody said it was 28. So 28 plus 4 is, so we're putting in 32. Who's my central atom? C. So we've got 1 C. How many chlorines? 4. And I need 32. And I've drawn in how many of those 4 bonds? There's 8. 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. All right, now I've drawn in all 32. What can you tell me about my 4 bonds? Are my 4 bonds equal? So my bonds are equal. Does my C have any lone pairs on my C? So I got no lone pairs, all my bonds are the same. Is it polar or non-polar? It's non-polar. Okay? So it's non-polar. So if it's non-polar, will it dissolve an ionic compound? I got several people shaking their head no. So it's no, it's immiscible. Okay? Now, what if I have one that everybody always forgets about? What if I have one of our diatomics? What do y'all remember about the diatomics? Are those polar or non-polar? All right, I have a polar, I got a non-polar vote on this side. How do we decide? The electronegativities. Very good, Betsy. All right, so what happens when I look them up, and then I think that was 2.5. All right, what do I do if I is 2.5? 2.5 minus 2.5, and what do I get? You get non-polar. So if it's non-polar, will it dissolve something that's ionic? No. It's going to be immiscible. Okay? Questions? All right, let's practice. Because I want to be able to do the math today, so we're not spending long on this topic. All right, so both sides of the sheet. It shouldn't take us long to do this for those of us who are trying. I rest of sleep. Somebody might want to get the papers off his desk and pass them back. All right, on the front side, you're doing what we just did. The back side, just answer some multiple choice questions real quick. And then we're going to learn to calculate with 2 formulas. Who scared you? What'd I do? I said hand the papers back to somebody.
You said do.
On the front, for example, if we do the first one together. All right, NaCl. What can y'all tell me about NaCl? It's ionic, right? So, will it dissolve in water? We all know about water. What we just say?
Yeah.
It's polar. So, will NaCl, which is ionic, dissolve in water? You can write yes, put a check mark there. I don't care. All right, will it dissolve in CCl4? What we just say about CCl4? That's nonpolar. Will an ionic compound dissolve in a nonpolar material? No. Put an X or write no. An alcohol? No. What do we say about alcohols? They only dissolve polar or nonpolar. So put an X or a no. Okay? To the next row. So what now?
Alcohol dissolve in alcohol.
Yes. Remember, like dissolves like.
Oh, right, okay.
How we doing? Questions? Anybody? Did you do the backside for those of you just sitting there? I told you to do the backside.
I'm doing that.
I even told y'all for those of you who are too slow to turn the paper over. Yeah, do the backside. You won't do it at home, so do it in class. Fabulous. No, it's classwork. We're gonna learn some math formulas here in a minute. Yes. Oh, Jennifer.
So much water.
Shut up, stop whining. Stop trying to.
All the time.
Yes, you do.
That's what I do that.
Destiny, you got it done front and back? If I walk back there, did you really answer the questions?
I'm guessing that.
You don't have to walk back here.
I already what you did do.
I didn't even start it.
Right, yes, I did.
You did some.
So,
Let's do that.
It's not done.
That's why he sent me back here. Do the multiple choice. Come on. It's more like it actually memorize me.
Are you gonna burn the other front of the class?
I won't argue on top of it.
Oh, my back. I'll start calling her you. Lily and you. As long as they all say home name. I'm going to say it every time.
Does your name have two N's or one N?
Shut up. Answer the question.
Oh.
You done, Dusty? That's not. You go.
I really do.
You really can.
I love it.
You're gonna hold it.
I'm considering this to be vulnerable. Well, can you come over here?
Did I hear somebody here sound? I know our voice was not rude. I'm not completely crazy. Yeah.
Can you help me with this?
Okay, what can you tell me about ethanol? It ends in this hotel. So it will dissolve or and non-polar. Anything that ends in OL is an alcohol. Okay, alcohol is dissolved both polar and non-polar. This one is non-polar. This is an alcohol, and that's a polar. Okay, so it's gonna dissolve here, here, and here. All right, that's a non-polar. So is it gonna dissolve in a polar? No. Is it gonna dissolve in a non-polar? Yes. Is it gonna dissolve in an alcohol? Yes. Now,
This is both, right?
yep. So this is one of your 7 diatomics. What do we know about one of the 7 diatomics? The diatomics are always what? What did somebody say about the diatomics just a while ago? They're always what? That's Bay. What'd you say about the diatomics while ago?
Oh, the non-polar dynamic.
Always non-polar. Okay, so if they're non-polar, yep. So we can check out that compound. So, onyx is involved in what? Onyx compounds is involved in, okay? Compounds involved in that, but not onyx. Okay? Yep. Okay.
I'm not looking at it, sounds good.
Okay, what do you know about CaOH2?
Is it ion?
Yep.
No, that's what I'm doing.
Hopefully.
Alright, let's look at the front side.
I'm done.
So if you look at the front, what can you tell me about NaCl? It's what?
Huh?
What can you tell me about NaCl? So will it dissolve in water?
Yes.
Will it dissolve in CCl4?
No.
Will it dissolve in alcohol?
No.
No. I2 will dissolve in water?
No.
No. Okay, it's non-polar, so no. CCl4?
Yes.
Yes. Alcohol?
Yes.
Ethanol is a what? Will it dissolve in water?
Yes.
Yes.
Yeah.
Alcohol dissolves everything except what? So it's yes for water. Is it CCl4? Yes. And alcohol?
Yes.
Yes. That whole row is yes. Benzene is non-polar. Will it dissolve in water?
No.
No. Will it dissolve in CCl4?
Yes.
Yes. Will it dissolve in alcohol?
Yes.
Yes. Br2 is non-polar. Will it dissolve in water? No. Will it dissolve in CCl4? Yes. Will it dissolve in alcohol? Yes. 5. Number 6, KNO3 is what?
Non-polar.
It's a metal and non-metal.
Oh,
It's
that's,
ionic.
that's what you said?
It's an ionic compound.
Okay.
Alright, so if it's ionic, will it dissolve in water?
Yes.
Yes. Will it dissolve in CCl4? No. Will it dissolve in alcohol? No. Toluene, I told you is non-polar. So will it dissolve in water?
No.
No. Will it dissolve in CCl4?
Yes.
Yes. Will it dissolve in alcohol?
Yes.
Yes. CaOH2 is ionic.
That's crazy. I got that one, but I didn't get it.
I don't know why. It is ionic, so will it dissolve in water?
No.
Yes.
Yes.
Ionic dissolves in polar, so yes.
Oh.
Alright, will it dissolve in CCl4?
No.
No. Will it dissolve in alcohol? No. On the back side, which of the following is an electrolyte? This was for our quiz yesterday. A, sodium chloride is ionic. Which of those molecular substances will conduct electricity? This one's a tricky one. Molecular means it has to be covalent. Molecular is covalent. So which one of those is covalent and will conduct electricity? B. It has to be an acid. Alright? An example of a non-electrolyte there will be who? Who's covalent? A non-electrolyte. Potassium chloride's ionic. It can't be a non-electrolyte. Who is covalent in that there? Several of you yelled the right answer. It has to be sugar. Sugar is the one that's a non-electrolyte. Hydrochloric acid is an acid. Acids are electrolytes.
Well, I'm not seeing it, but you just kept saying that.
That's what I said. Several of you had the right answer.
What's the election?
Guys, yesterday on the quiz, when we talked about this, electrolytes.
Oh, no. Oh, my God.
Go on board. We're going to be here. Strong and weak electrolytes were ionic, acids, and bases, right? Non-electrolytes were what kind of compounds? Covalent. All right, so in question number, which one here? 3. It says a non-electrolyte is which one of those? If y'all are yelling B, hydrochloric acid is HCl. What is HCl? It's a strong acid. It's up here, a strong electrolyte. It can't be a non-electrolyte. Okay, stop yelling that. Sugar is C6H12O6. That is made of what kind of elements? Yes, but there are what kind of elements up there, not what the elements are. They're all covalent. They're all non-metals. All non-metals are covalent. They're your non-electrolytes. Okay? Which will dissolve most rapidly? And number 4.
Number 4, D.
D, powdered, because it's smaller, it has more surface area. Remember we talked about kinetics? Smaller pieces and hot water. Higher temperature, bigger pieces dissolve smaller. Make it bigger or smaller surface area, higher temperature. So D. Same thing in number 5, most slowly. All I did was ask the same question a different way. Most slowly will be what? Large crystals, unstirred. A. The solubility of a substance can be expressed as grams of solute per 100 grams of water. C. All right. An example of a non-polar solute, like from the side 1 of this worksheet, would be B. Carbon tetrachloride. Number 8. Which of the following would be soluble in water? What did we just say was soluble in water on this side? What kind of compounds? Polar or ionic. So what do you have in number 8? Polar or ionic is listed. A is what kind of compound? Ionic. So it's A. Number 9 and number 10 are the 2 that cause the most issues, or should have on this worksheet. The 2 that are immiscible means they won't dissolve. A is miscible. Water and ammonia are both polar. B, water is polar and alcohol. Alcohol will dissolve in a polar, so that's miscible. C, carbon tetrachloride is nonpolar. Benzene is nonpolar. The answer is D. Benzene is nonpolar. Water is polar. Guys, they were all from the front side of the worksheet. All you had to do was look them up.
10, what's 10? It's a C.
Number 10, which is a solvent for polar and non-polar solutes? C, it has to be an alcohol. All right. Now let's talk math for our remaining half hour.
Class is over.
You keep thinking of that. Now, the remaining piece of class, and I'm thinking I have this. Yeah. If you look on your reference table, both of these formulas are actually on your reference table. So the nice part about this is you don't have to memorize either of these formulas. The other nice piece about these formulas are we've already done all the background for these formulas. So we're just putting together information that you already know how to do. Now, concentration. All right? Concentration is the number of particles per unit of volume. There are multiple types of concentration units we can calculate. We can do molarity. We can do molality. We can do percent by mass. And we can do normality. Normality has been taken out of the curriculum for probably 25 years. Molality has only been out for about 4. Percent by mass has been out for about 10. Now the state only wants us to do molarity, so that is the only one that we're going to learn today. All right? Now, you might be asked about something being dilute or concentrated. These are 2 words that we use all the time in science class, and we just assume students know what they mean. All right? In terms of solute and solvent, what would it mean to say something is dilute? What would you have more of if you had a dilute solution? The ones that you used Monday in lab were pretty dilute. So what did you have more of? Yes. Okay? And something that is dilute, you have less solute and more solvent. So those of you who are like myself, according to my third period, who actually follow the directions on the Kool-Aid package, my Kool-Aid is too dilute. There's too much water in my Kool-Aid and not enough sugar. Now, my third period class will tell you that their Kool-Aid is more concentrated. They add more what? Okay, so they have more solute and less solvent. All right, now, dilute and concentrated are important for lots of reasons. All right, if we were to talk prescriptions and medication, if you were to go to the doctor and get one that was too dilute, it would not fix the problem and you would have to go back because it would not clear up the issue. If you had one that was too concentrated, it could cause harm or quite possibly kill you depending on what the medication was that you were taking. All right, now, for Kool-Aid, of course, it would just be taste. If you were diabetic, of course, it could increase your sugar level to the point that it could cause issues there. Now, we are going to talk about the two formulas that you have to be able to use. They're both very easy to use. Does everybody have what they need? Tell me when you got it. Okay. Now, the first one is the molarity formula. All right. Now, molarity is defined as the number of moles of solute over liters of solution. Now, everybody in this room, regardless of your average, can calculate grams to moles. I don't believe there's a soul in here who can't do that at this point. I'm pretty sure. I might be wrong, but I'm pretty sure. All right, everybody in here can change liters to milliliters or milliliters to liters. All right, even if you can't do the King Henry died very well, milliliters to liters, we divide by what? 1,000. Okay, I told you to memorize it if you didn't know it, because we use that so much during the gas laws, it would just make it easier for you if you knew that. Okay, now I'm not going to write that equation every time we need it, so you're going to see me shorthand it like this all the time. Big M is molarity, and then moles over L for liters. Okay, now you've seen the units for this already when we calculated equilibrium, because the concentration were in these units. Sometimes we wrote the units as big M. Sometimes they wrote the units as moles per liter. You can write it either way. I don't care. I tend to write them as big M because I'm lazy. Sometimes we write them as moles per liter. I try to change it up just so you get used to seeing both. But big M is just easier because it doesn't have a fraction. But I don't have any preference as to which one you use. Okay? Using the formulas, though, are very straightforward. They are some of the easiest formulas we will do in here. Does everyone have what they need? Can we do one? All right, so suppose this is our question. Tomorrow on the benchmark. What is the molarity of a 225 gram of glucose and 750 milliliters of solution? And I'll let you write it down while I look at Friday's schedule. There's no grab and go Friday either, by the way.
Are we still gonna go to first and second?
That's what I'm looking at right now. You will be in first from 8:20 to 11:30 for the assembly. I dare say you will get virtually no time for a first period to really take place for teaching. They're estimating 9 to 11 for senior assembly. If it's shorter, I mean, if it ends at 10:30, I mean, you'll have time for first period to teach, but I don't know exactly, how long it's gonna go. Third period is roughly 11:35 to 1:25. So it looks like with lunch for a half hour out of that, it's still gonna be pretty close to an hour and a half for third period, so third's not gonna be altered much. Second and fourth are in the afternoon, and they're about an hour each. Huh? Benchmark is Thursday.
We have you
This
last.
is Friday.
We have you last.
You have second right after third, so I'm after lunch, and then fourth is dead last of the day.
We will talk.
Go there like the actual,
Like 1:30 to 2:30. So what?
go there like an actual assembly for like the seniors, like we should.
They have what, actual what?
Like so, like assembly, like a senior prep rally, like what you call it, like the last year.
No, it's just the senior assembly. Yeah, then y'all are getting on the bus and going wherever they're having your picnic at.
Yeah, they said they're not doing D-Day this year.
No, they're not.
You're not doing what?
Yeah, with the pep rally. As far as I know, they're not. I've not been told that they've changed their mind about that.
Sure.
All right, so how do we calculate molarity? All right, the formula is what? Molarity equal moles over liters, right? Now, this is why I say this is easy. Grams, you all know, has to be changed to what? Moles. Liters and milliliters have to be changed, right? So, 225 grams. What goes on the bottom? What goes on top? Do we have a balanced equation? So what do you know goes beside moles? Now, how do we find grams? Formula mass. Brian even used the right word. So how do we get our number of C's? How many H's? How many O's? The mass of carbon? The mass of hydrogen? The mass of oxygen? 16. Remember, 14 is nitrogen. Don't make dumb mistakes like that on the exam. Look it up if you're not certain. 72, 12, 96, I believe. Total's 180. Where does 180 go? Next to the grams. Where's the calculator? Is what? It's a number. I got that on my own. 1.25. All right, so that's going where moles is. All right, what do I do to get my volume? 750 divided by 1,000. Okay, so I get 0.750. What do I do to get molarity? That's it. 1.25 divide 0.750. I get big M equals 1.66. And I'm going to put big M on the end because I'm lazy like that. And I'm not going to write moles over liters. That's the answer. Any questions? Can we try where we solve for one other variable?
What?
Just to get some, can we try where we solve for a different variable, just where we have some variation? Okay. Everybody have what they want? All right. What if I asked you on the benchmark tomorrow to do this one? Or I ask you to find grams. How many grams of sodium hydroxide are needed to make 500 milliliters of a 1.5 big M solution? All right, what if I ask for this? What's different about this one?
You gotta change.
What am I giving you here that makes this one different? Dusty, pay attention. What am I giving you here? I'm giving you the M, okay? So if you look at the formula this time, big M equal moles over liters, I'm giving you the big M, 1.5. Do I know my moles? No. Do I know my volume? All right, so what's my volume? All right, I got 500. Now I gotta do what to it? I've heard a couple people already give me the answer. Go ahead and divide by what? That's right. So take your 500 milliliters and change it to 0.5 liters. All right, so how do I solve for my moles? What do I do with that? I got to do what? I heard a couple different answers there. You're doing what? Cross multiplying. Thought I heard a couple people say divide. 1.5 times 0.5 is 0.75 moles. All right, now, some people will stop there on the benchmark or the exam, and they're going to probably have that answer. But is that going to be a mass or a grams? No. What do you have to do from that point? Convert it. All right, so you've got to go moles to grams. So what goes beside moles? And where am I going to get my grams from? What am I going to use in the question? NaOH. So how many NAs do I have? How many O's do I have? How many H's do I have? That makes it nice and easy. How many? 23, 16, 1, told us 40. So you get 30 grams. Any questions about how we did that? All right, ready for the last formula? Last one's like the gas laws. It's even easier. All right, the last question is this one. All right, when I make acids, do I buy acids that are made to various concentrations? No. Okay, you don't even really have to write what I have in purple up there. All right, I buy 12 molar HCl. Okay, I buy it in bulk. And then I dilute it to the concentration I need. And I have 3 bottles back there because they're the most common that I use. I have it in 0.1 molar, I have it in 1 molar, and I have it in 6 molar. Okay, and those are the concentrations that we use this semester. Now, if I need, let's say I need a 3 molar, I just make 3 molar. If Ms. Thornhill comes over and says as well, I need a 0.5 molar. Can we make 0.5 molar?
Yes.
Yes, we can. The way we do that is this formula right here. So if you read a question and it says in the question to dilute something, this is the formula you want. What does the big M stand for? Molarity. What does the V stand for? Volume. Now, the only catch to this formula is the units have to what?
Match.
Have to match, just like the gas laws. Okay? Other than that, there is no requirements to this formula. The units have to match. The big M's are already going to match because they're going to be molarities. But the volumes just have to match. They can both be milliliters or they can both be liters. It doesn't make any difference as long as they match one another. Okay? You with me on that? Somebody actually write in the purple. I was going to say, I told y'all not to. All you need is this and this. Y'all got that? Okay. So, I told you not to. All right, so write that down, and we'll walk through how to do a sample of dilution. Dilution is probably one of the easiest formulas we ever do. And then we're going to practice a little bit. Because at this point, you'll either be, out of the 40 questions tomorrow, I think there's about 5 you won't know how to do. And we're going to pick up 2 of them Friday when we do nuclear. And then I'll try to get a couple of them on Tuesday with some acid-base stuff. And then there'll still probably be about 3 you might not have how to do during the exam out of 45. 3 out of 45. I can't fix it for you on the 5. You're still in better shape than last semester by a long shot. Steve, questions on acids and bases. And I'm going to give you some strategies to eliminate answer choices. Huh? I mean, I'll show you how to eliminate some stuff, and I can show you how to, but y'all just won't come after school, and I'm not going to waste my time trying. Remember, today's the last full day after school, and then tomorrow I'll be here for a partial till about 4:15. And Juliana, that lab you shared has still not come through my email. Do you have a way to print it? See if you can get it printed. Or try sending it to me again or sharing it, but can you email it to me directly instead of sharing it through Google? Because it has not come through. I keep checking. All right, when you look at this, just like with the gas laws, how many milliliters of HCl do we need to make 350 milliliters of 0.750? See how it says of 350 milliliters of 0.75? It's a couple or a pair, okay? That 350 has to stay with a 0.750. Doesn't matter if this is V1 and that's M1, or if that's V2 and that's M2. The answer is no, as long as they're together. So when you go to fill in your M1 V1 equals M2 V2, all you need to do is make sure these two numbers are together on one side. Doesn't matter which side, just together on the same side, okay? So I tend to just put them on the first side. So the 0.75 is M for me, and the 350 is V. I just need to remember that that's milliliters, so my volume I find is going to come out in milliliters. So the 12 molar is going to be my M2, and my V2 is what I'm going to find. So all I have to do to solve is what? Multiply and divide. It doesn't get any easier. So we're going to divide by 12 over here and divide by 12 over here. So V2 is going to equal 0.75 times 350 divided by 12. And I get 21.8. And again, the units have to match. So it's got to be milliliters because that's what my 350 was. Okay? So let's practice just a little bit. Let's see here. Yeah, these are good. Let's do the odd numbers. Huh? It is gloomy. It's going to be gloomy all week. I hope it improves for the weekend.
Timothy. Do you have an extra water in this wall? You probably do.
I'm probably doing that just won't share. All right. I was giving you some calculations. I want to do the odd numbers. So we're only doing 5 of them.
Can I see something? That's in the schedule.
Yeah.
Did it hurt?
Thank you. All right. So the first 3 are on molarity, and the last 2 are on dilution. Okay?
You said odd?
The odd. Gabriel, big head up. You and I both know you want to go over homework, so let's get them done before you leave. You got 10 minutes. Let's get them done. Got 11 minutes, actually. Come on. You can get them done in 11 minutes. They're not that hard.
Because you're smart as well, or not? Well, I mean, I'm kind of smart.
Y'all are smarter than y'all give yourselves credit for. Come on, you can get these done.
Oh, okay.
Gabriel, are you calculating on your phone or playing on your phone? Uh-huh. I don't believe you.
You don't believe me?
No.
That's good.
I forgot.
All right, we'll prove it. Well, that's a calculator.
Okay, could have just pulled that up too.
Yes, clearly put up the Na plus Cl. Yes, clearly.
Yep. Yeah,
This is how it works. Are you gonna check?
it is very possible. I've not checked in a while. I might just be feeling the urge again.
I hope you check.
I'll check it too. Hey, can we round up?
Yes, you can.
You said the odds, right?
Huh? I said the odd number. We're only doing 5.
Yay.
Chest.
No. You said just odd.
Just us. Y'all think I'm trying to trick you or something?
No, I just wasn't listening.
Eric, what are you doing? What, Jennifer? No, because they're not on the same.
So, do you have a reason?